Hey, everybody. Welcome. Thank you for joining. Welcome to this week's edition of Data Viz Friday, where we are going to be talking all about funnel data and funnel charts. We have a great notebook to review this week, so we're really excited to jump in. We'll give everybody about a minute to join us. While we wait, let me quickly pass it over to Elijah. Elijah, do you want to give a quick intro?
Yeah, hi folks. It's Michelle and Dave and I from Notable. My name is Elijah Meeks. I have a long background in data visualization, and especially with D3, especially with JavaScript. Used to work at Stanford doing digital humanities stuff, and then at Netflix. In fact, at Netflix, I did a lot of these funnel diagrams. So I'm real excited today to talk about funnel diagrams. They're a favorite of mine, just a longtime favorite of mine. So I'm happy to get into them. But like you said, Michelle, we'll wait and let folks trickle in. I don't see the YouTube in front of me, so you'll have to let me know when you think we've hit critical mass.
Sure. Yeah, we'll give it maybe 30 seconds to another minute. So folks who are already on, thanks for joining. We'll just give folks another minute or so to join. I know it's top of mind right now. Dave, you have kids, right?
Absolutely.
I have kids. Daylight savings time. I don't know what everybody, folks on the stream feel like, but daylight savings time this weekend, I am stressed. I have young kids, so I haven't really been through it that many times. Do you have any tips, Dave?
The only good news is, when they wake me up Sunday morning, instead of it being 5:30, it'll look like it's 6:30. So I feel like I've slept in. I've got a restful weekend. So there's that bonus. But yeah, Monday morning, RIP for all the parents out there dealing with.
Is there one that's is the other one better when it goes the other way?
No, then it looks like it's 4:30 that they're waking us up, right?
It's all bad. I think we're team no daylight savings time. Maybe we could do a visualization on that.
I think we should do the classic heart attack data set, and we should find out how many people are having heart attacks every daylight savings for the last 100 years.
Yes, there we go. All right, Elijah, let's get this going. It looks like we've got a good group of joiners, so I'll kick it over to you to get things going.
Thank you, Michelle. So as with last week, I'm gonna work through this notebook that we've developed. So Notable is a notebook platform company. We build out this Jupyter notebook with all sorts of improvements, but that doesn't mean that you have to use Notable to do any of the stuff that I'm showing off here. This is all just sort of fundamental principles about funnel data and working with funnel data, and especially with the different kinds of funnel visualizations that you might use to expose different patterns. So there's a nice introduction here. I would recommend, if you are working with funnel data or you're thinking about funnels, that you take a look at this piece I wrote called "We Live in a World of Funnels." It just talks about the concepts of funnels more broadly, and I think it's pretty valuable. And then I've got another link here to a tool called Sankey-Matic. So you're going to see a lot of Sankey diagrams here. And the Sankey diagrams are always popular. They're still not the most accessible diagrams. People still misread them. But it's a great tool for playing around with network data sets and producing Sankeys. So what we're going to talk about today is ways that you look at flow data, funnel data, the movement of things through systems. And I have to be very vague and generic like that, because most people, when you talk about funnels, they think of whatever funnels they typically work with. So if you talk to a salesperson, you're going to talk about the sales funnel. If you talk to an HR person, you can talk about the hiring funnel. And if you talk about people who work with websites, then you're going to see clickstream data, and you're going to talk about how people move through websites and move through online stores and things like that. And we're going to see other kinds of funnels too later on. But basically, we're going to touch on a few of the funnels that you see in this quadrant. So there's the classic graphical funnel. I call it a graphical funnel because it looks like a funnel. There's just taking that graphical funnel, putting it on its side, and looking at it as a bar chart. So that's basically what you're doing, is you're showing every step in the funnel as an individual segment. So a graphical funnel that's top to bottom. Bar chart funnel, it's left to right. You've also got the sunburst, which used to be very popular because of a paper by Kerry Rodden out of Google, which first showed using website data, clickstream data as sunburst. And it was very popular for a while in tech, and sort of almost the expected way to look at movement through websites. We're going to look at arc diagrams as funnels and tree diagrams. And then there's the good old Sankey. These Sankeys are probably a little bit different than what you're used to because they have cycles, meaning we can see recirculation, which makes them much more complicated. And then also there's just literally showing the individual paths using typically icons, but sometimes just colored circles or colored squares. So the first step with funnel data is making data that you can show in a funnel. So typically what we get when we're talking about like clickstream data or any kind of data, when we talk about row level data that feeds into making funnel data, it's these individual steps in some cohort's life. So I say cohort because, for you, it might be users, for someone else, it might be packets moving through a system. So each one of these has an individual ID. So in this case, we're talking about, people moving through a website. So it's user one, that might be instead named Dave, or it might be Michelle, if we know who these users are. The page that they visited, so the step that they went to, when they went to it, and then whatever kind of categorical information, whatever kind of metadata you want about that. So everything after that, other information, you could have 17 columns after that. What you need is these first three. So the nice thing about a notable notebook is it allows you to use SQL against CSVs, or use SQL to connect to data sources. I prefer SQL to pandas because even though I've used Python quite a bit more in my later career, I'm still much more sort of comfortable with SQL. So I like using SQL cells. So I'm going to load some example data from the CSV. And this example data looks like this. It looks like the data I just showed you, right? You've got a user ID. I didn't come up with people's names. I just gave them numbers. The web page they hit, the timestamp that they hit it, and I just used a very naive number. But this timestamp, would probably out in the wild be some kind of actual timestamp. And then the location and whether or not it was their first visit or not. So this was that sort of metadata that maybe I wanted to slice and dice it by. So I've got 3 locations: California, Colombia, and Colorado. And this is data that you could analyze, right? I'm not trying to pretend like there's not something you could do here. You could get a count of the users from each of their locations, or you could get a count of the web pages that the user landed on. And that's nice, right? We can see that the login page got the most, and we can see, hey, here's something going on here. The old checkout, which obviously is a deprecated page, somebody landed there, so that shouldn't happen. So there, we found some insights in that row level data. That's great. But really what we want to do is we want to look at a funnel. We want to look at how people are moving through the system. And to do that, we're gonna transform the data. And this is just a SQL query. I'm not going to go through the whole thing, but all it does is sort of flip it, right? So that instead of it being about individual users and their steps, instead, if we go take a look at this, we take it so that we count the steps. We count the number of users that hit each step. So we have one user that hit the home page, one user that hit the login page, one user that hit the cart page and the shop page from Colorado, and so on. And so now we've got these individual rows that are grouped by the username, right? And the location. That's all the SQL query is doing. It's just flipping it and grouping it by location and user ID. So I get one row for every user, location that combines all of the pages that they happen to visit. It doesn't know anything about the order that they visited them. And with that, we can sort of look at funnels. We can look at all sorts of different kinds of funnels. We can look at a very sort of graphical funnel, which if we go in here, I've organized this funnel in a way that makes sense to me. So it doesn't know any kind of order. So I could have started it in different orders. And it doesn't assume that it should be in the order of greatest to smallest, because that's not necessarily how your funnel is going to work. It's just based on whatever order you put those metrics in. And this is real nice. A graphical funnel is very nice because a graphical funnel is very readable, right? And mainly because we put the numbers on the funnels, but also because people see it and they think it's a funnel. And that's an important aspect of data visualization. If your audience expects something, you typically need to give them what they expect. Now we could go in here and make this a little bit more sophisticated. We could, because we have location, we could split it by location. And then it becomes a little bit less. You wouldn't want to use this funnel to, I don't know, put olive oil into your decanter. But this does show you some interesting information here about how the difference in visitors from Colorado versus Colombia versus California. But typically, this is kind of funnel that people are expecting. By creating the data like this, you don't just have to put it into a graphical funnel, right? You could take that same data and you could look at it in what's called a dendrogram or a tree diagram. And this is very interesting because what this does is it shows the decision points that people make, these different cohorts make. So under the hood, what it does is it combines all of these aggregate pages that people visited in the order that you suggest based on that UI over there. And then it combines them, and then it splits them at each decision point. So some people went login, and they hit the login page, they hit the home page, they hit the cart page, the checkout page, and the shop page. And some people never hit the home page. They hit the login page, the cart page, the checkout page, and the shop page. And that's very interesting. This is a different kind of analysis you're going to want to do. And from the perspective of network analytics, these are what are known as motifs. Now, out in the wild, when you see a motif, you'll typically see just this straight line here, right? Cart, checkout, shop, because that's how you define a motif. A motif is a unit of analysis that you would use in data science. You declare that this is a path I'm looking for. I'm looking for cart, comma, checkout, comma, shop, because that's an important path for some reason in how I'm looking at this system. What I like about these tree diagrams is that they show you the motifs, but they show you the motifs plus these sort of decision points. And so it's almost like an aggregated motif view. To be clear, and I'm not sure if I'm being 100% clear about this, out in the wild, when you see motifs, you're not going to see people associating them with these dendrograms. You're going to see them associated with these straight line paths that are typically defined by the researcher. What's nice here is I can say there is a cohort here that really did just hit these pages. And that's a path. As opposed to a flow, right? When I look at like a Sankey diagram, I know that this many people went from login to home. I know that that's encoded in that big fat edge that's connecting login to home. And I know that this many people went from home to shop. There's another fat edge there. I know that that encodes that. But I have no way of confirming that the people who went from login to home were the same people who went from home to shop. We've got a little diagram that is somewhere around here. This notebook's too long. There we go. That sort of explains the difference between these. So a flow takes all of these paths and then it aggregates them at each of the node to node steps. And a path is a specific route through the system. And which one is better depends on what your analysis requires. But what's important to recognize is that these different charts are going to preference those different views, whether they're flows or paths. There's another, this is actually, the sunburst diagram is very similar to the dendrogram. Under the hood, for those who are familiar with sort of D3 or other data visualization libraries, you'll know that it actually uses a lot of the same functionality to generate this. So really what's different here isn't the metaphor of the steps. What's different is the emphasis in the steps themselves rather than those paths. So what you see, just because of visually how a sunburst represents movement through a system, what catches your eye more is the shift from one color to another, meaning one path to another, meaning one state change to another. So the unit of analysis here is more looking at, hey, this goes from yellow to dark blue to orange. But when it goes from yellow to dark blue, a lot of it goes from yellow to orange over here. And then you could notice that if I'm looking over here, however, yellow to dark blue to orange, it doesn't have a lot of that orange in that middle step there. So what's going on there? And you could look into that. Now, that's just doing this sort of naive aggregation of your data, which is very valuable. But I want to try to talk about maintaining the actual integrity of the individual paths that your individual cohorts went through. So in this case, our users. We want to actually make sure that we know the order in which they moved through the system. The reason why is that no matter what you do, no matter how you view this data, it's all going to have this nice clean flow from login to home to shop to cart to checkout, because you defined that flow. You said that that's how I built the data. That's not really how people move through systems, though. We've all been caught in that moment when we try to log into a site and it sends us back to the login page. We think we've successfully done something and we end up in some error state. So those are cycles where we end up back where we were. When you're trying to optimize applications, whether they're web-based or not, you'll find out that some people manage to skip steps that they shouldn't be able to skip. And that's another error state that you want to identify. So to do that, we have to make a more robust kind of data. And that's what I call path string. The path string is very simple. It's literally just a comma delimited string that designates the steps, in the order in which a cohort actually took them. So we do that in SQL using something like a group concat function. You could also see this in certain flavors of SQL. It's called string add, where we take the web page column and we aggregate that column into a comma delimited list, grouped by the location and ID. And then we count the number of visits because we know each of those rows is a single visit. So we take that from funnel steps, we group it by location user ID, and that gives you back data that looks something like this, right? We can see the order in which people move through the things. I'm taking a pause because actually I realized that my SQL statement is wrong. I shouldn't be counting star, because actually in this case, what I'm counting is I'm counting the number of steps. What I should be counting is actually the distinct number of users in here. And I'm not going to rewrite this query. I will rewrite it, I promise, for posterity on the video. I will rewrite this query. This isn't counting the right thing here. But of course, this is what happens whenever you do a live stream in front of a whole group of strangers, right? That's when you find out your SQL statement is wrong. But that's all right. This will be fixed by the time the rest of you come back to this notebook. This will be fixed. But fundamentally, what I'm talking about here is instead of counting star, which you'll notice all I'm counting is the number of steps. That's not what I want to count here. What I want to count is the number of users who were on this. So I want to count I want to do a count distinct on the user ID. Well, which, like I said, I'll fix later. But imagine this was a valid metric column. What we have here, the important thing that we have here actually is the path string column. And the path string column is talking about the order in which users moved through this website. And you'll notice something, that there's one user here that went through this website and all they did was hit the login page 5 times, right? We've got another user who went to home to log into error, to log into error, to log into home, to log into home. And you can imagine the frustration represented in a path like that. But more than just the frustration, what's interesting about these paths is that they show cycles, and cycles are problematic. If we suddenly look at this data set, we notice that there are a lot of users who are stuck in the home page. We see a lot of users who can't seem to get out of the login page. We see users who are moving back from the cart page to the shop page. That actually makes sense. That's not a problematic cycle. So cycles are not by themselves problematic. And then the other thing we can see is the order in which they move through the site. So these Sankeys have gotten much more complicated. This is the problem with funnel analysis. So this is what you have to weigh in determining which funnel diagrams you're going to use. But this is the only way that you're going to see people skipping steps. Like somehow people are getting from the home page straight to the shop page, or somehow, which maybe is the right path, in which case, why are so many people going to the login page? How come so many people are going straight from the login page to the cart page, and so on? Why are people skipping what seem to be the what they call the happy path, the expected flow through the system? So by building this path string data, we are maintaining the cycles and skipped steps that we would never get with that metric funnel approach. The metric funnel is cleaner, It's easier to conceive about, but it is not going to show you some of the most important units of analysis when it comes to network analysis for funnels.
Elijah, quick question that came in
You got
from
it.
viewers here about the path string. You talk about kind of creating that path string. Is that something that the user needs to create themselves, or does that potentially come from certain data sets already that will have to be formatted in this fashion?
So there are some data sets that will show you comma delimited steps in order. I haven't seen too many out in the wild. There's one of them we're going to get to down at the bottom, but it doesn't seem to be sort of outside of this one unexpected use case. It doesn't seem to be a very common pattern. And it's not a very common pattern because funnel diagrams still aren't very common. They're typically tied to products. So you're typically only seeing them in Google Analytics, or you're seeing them in some built-in product where the product itself is behind the scenes doing some of this for you. But I'll leave that actually to the viewers at home. I would love to hear about any examples of seeing this out in the wild. I felt very proud of myself because I thought I came up with it back when I was at Netflix, and then I found out, of course, that I hadn't. And I used it in various applications for funnel analysis, step analysis at Netflix, at Apple, and now here to great benefit. But I haven't actually seen it very much. And when I've explained it to folks, it seems like it's not sort of common out in the world. I just wanted to show, we can still get those motifs. You'll notice the motifs now are much more interesting, or at least they're more complicated because, of course, people are starting in different places. They're splitting off in different places. Things that we lost when we were looking at this exact same data, but from that metric funnel perspective. So there's some nice stuff in the notebook. I welcome you to take a look at it. We're gonna probably have a little bit more material that we're gonna put out in the world about these, like reading funnel diagrams. So stay tuned for that. Talks a bit in the notebook about the things you might be looking for. I've already spoken to this about drop off, like when people are leaving the funnel, skipped steps, cycles, and this concept of motifs. So I want to get down to the bottom and talk about other kinds of funnels, right? I love people analytics. One of the ways we used funnels over at Netflix was a great time when I was working with people analytics team. You'll see them use funnels for like the hiring funnel, for how candidates move through the hiring process. Now I saw an example on Reddit, Data is Beautiful, that had 17,000 likes that I thought was very amusing because I thought it was kind of like an HR funnel, and it was the way that someone was not having the most success in their romantic life. And the reason why I wanted to put this up here is because this got, first of all, it got 17,000 views on Reddit. So obviously people thought that was an interesting use of a funnel. But also, this is literally only 6 rows of data. Like I just hand wrote this. I saw it on Reddit. I hand wrote this in 5 minutes. And it created this incredibly interesting like chart that's gonna arrest viewers, right? That's gonna draw people in. So yes, you'll need to use SQL queries on real robust data, large data sources, but also there might be some mind mapping that you could do with funnels. There might be some simple funnels that you might use in just to communicate sort of concepts like these out in the world. On the other side of things is the idea of the flame graph. And this is what I was really excited about, because the flame graph is not typically thought of as a funnel. And in fact, let me go pop this open so our flame graph gets a little bit smaller. I want to just jump to the table view of this real quick. And this is the raw data that came out of like a dependency tree. And it was the cost, and whatever the cost was, whether it was some kind of units of processing, typically it's time for a flame graph. But sure enough, here is this comma delimited list of all of the dependencies that something depends on, whatever's at the end of that list. Now, it wasn't comma delimited when my data engineering co-worker at Notable, Dave Shoup, when he gave this to me. It wasn't comma delimited, it was semicolon delimited, so I had to modify it there. And then I had to tell Python that please let me have strings that are enormous, because these are very long strings. But sure enough, once I got it there, that wasn't actually very much data processing. Once I got it there, I could go look at funnel diagrams. And let's try to get it to the one that I want, right? Which is, you'll notice the icon saying a sunburst, because this is a sunburst. The sunburst is what's known as a partition layout that just happens to be radially projected. So this is a flame graph. And in fact, I think this is a much more visually impressive flame graph than your typical flame graph. But if you're showing this to your data engineering friends, you probably want something like this. This is a funnel, right? Whatever it is that is the cost to run this process and all of its child processes that have all of these dependencies, that have all these costs, is a funnel. It's actually the only thing I've seen in the wild that has that path string format. And sure enough, you can load it into the system and you can look at it. And you can look at it in, you can look at it in ways that maybe aren't particularly useful. So, but it's there for you. I am not going to show you the Sankey version of this. It's just a wild mess. Oh, and finally, what I wanted to talk about is, because we've looked at so many Sankey charts and things like that on here, I wanted to point out that there are other ways to get to these diagrams. So a quote funnel Sankey is just a way of using the Sankey diagram to show funnel data. It isn't tied to this idea of making quote metric funnels or path string funnels. That's just a convenience method that we've built into the product so that you can get all of that wonderful, those cycles and everything. Out in the wild, when you see a Sankey, a lot of times, like if you're using that tool like Sankey-matic or something like that, you'll see data that looks much more like this, which is what's known as an edge list. It's a network data format where you declare a source and a target, and sometimes a magnitude or a value. And so by having a source and a target, by having data like this, the type is just, again, just metadata. You can create Sankey charts very easily. And this is another popular kind of Sankey chart that's living out in the world, where they show the breakdown of cost and revenue to show operating profit for these companies. This one was Netflix. Pretty straightforward to build, but I just wanted to put it in here so that you knew that there were different ways to build these things, and you could build the same funnels you had up there. But the reason why I prefer that path string funnel than going that next step in aggregating these into an edge list is because that path string funnel maintains the history of the actual individual paths. Whereas once you get to an edge list, you have to, by necessity, you've boiled it down so much that you've lost them. So that's my end for funnels. Hopefully folks found this useful. I'm not sure if we've got any more questions in the chat.
Yeah, we got one more question, actually, going back to the path string. So the user asked, how do you prevent the redirected paths resulting in crashing the Sankey, like in the basic D3 Sankey visualization?
So the basic D3 Sankey doesn't support cycles. This is a version of a Sankey called D3, I want to say secular Sankey or circular Sankey, by a friend of mine, Tom Shanley, from who I said to Tom years ago, Sankey should support cycles, Tom. And Tom, for some odd reason, just went and did it. So big props to Tom for building this beautiful library. And so under the hood, Notable's tool for data visualization, we call it the DEX. Under the hood, DEX uses a library called Semiotic that I've been developing for a long time. And my apologies for not releasing Semiotic 2.0. I know that it's something that I should get out of these stupid release candidates and release. Semiotic uses that cyclical Sankey library under the hood. So that's why it was relatively easy for me to put this out there. But that's correct, that's true. A lot of the Sankey libraries are gonna just break on cycles.
I guess it's just one kind of like final kind of wrap up question here. So, I mean, obviously, we've seen how powerful these visualizations are, thanks to this presentation today, but is the biggest challenge in your mind, just about the kind of the formatting the data like we talked about before with the path strings, or kind of getting the data to be funnel friendly, to be able to use this type of visualizations?
I mean, I think out in the wild it is. Well, no, actually, no, it's not. Out in the wild, so you can see that formatting the data is pretty straightforward. It's actually like there's literally 2 SQL queries and one mistake in one of them that I will fix. But that group ag, that string ag, the string ag or group ag where you create the pass string is a slightly more complicated if your data isn't already sorted in the order of the timestamps. So you'd have to add that sort to the actual string ag function, which maybe I'll throw in there just so people can see it. My data was sorted because it was dummy data. To me, that's very conceptually, it's actually really straightforward. There aren't I don't know how many tools, frankly, there are in the world, except for maybe these flame graph tooling, like little flame graph products that are out there, that then will slice that up and produce network amenable data sets for it. So in that regard, I suppose that's something that you're not going to see too often. That's something that DEX does because of my background in funnels, dealing with this for years and years. I'd love to see more and more people support path strings. I think that funnel analysis is incredibly powerful. Like I said in that piece, I think we live in a world of funnels. I see it everywhere. And I don't think that you should be wedded to like a proprietary tool like Google Analytics just to get a chart of the flow through a system. I wanted to point out one of the fun things also in DEX, and I guess this is showing off the product a little bit. You'll notice over on the right, I'd forgotten, but over on the right, we opened up the comment window. And DEX allows data level commenting. So you're not just leaving comments on the cell like you would with a modern notebook platform. You can also leave comments directly on the data, so directly on a node or directly on a point in the scatter plot or something like that. So you can actually have the conversation about it, about the insights you see in the data on the data. And then we take a little screenshot of it over here so that people are aware of what the data looked like when they left that comment.
Awesome. Great. Thank you so much, Elijah. Thanks for walking us through this. And to everybody that joined, thank you for joining us. And we will hopefully see you next week for Data Viz Friday. And a little teaser is that we are going to go deep on bar charts. So you may think you know all about bar charts. You don't. There's more to know. And so join us next week. Thank you, everybody.